NFPA 79, which stands for the Electrical Standard for Industrial Machinery, focuses specifically on electrical safety for industrial machinery. This includes control panels and programmable logic controllers, or PLC. NFPA 79 provides comprehensive guidelines for the design, installation, and maintenance of electrical systems used in industrial machinery. The scope of NFPA 79 includes several key areas. Firstly, it covers general requirements that apply to all aspects of electrical systems in industrial machinery. Secondly, it addresses control devices, including switches, sensors, and other components used to control the operation of the machinery. Thirdly, the standard provides guidance on motor protection, which is essential for preventing damage to motors and ensuring their safe operation. Fourthly, it specifies wiring methods, dictating how electrical conductors should be installed and routed within the machinery. Fifthly, wiring protection is covered, ensuring that wiring is adequately protected from mechanical damage, environmental factors, and other potential hazards. Sixthly, the standard includes requirements for safety devices such as emergency stop buttons, light curtains, and safety interlocks, which are crucial for protecting personnel from hazards. The NEC, or National Electrical Code, is a general-purpose electrical code that applies to all electrical systems in buildings. This includes commercial, industrial, and residential buildings. The NEC provides minimum safety requirements for the installation, maintenance, and use of electrical equipment. Its scope includes several key areas. Firstly, the NEC covers general requirements that apply to all electrical installations. Secondly, it addresses wiring methods, specifying how electrical conductors should be installed in various types of buildings and structures. Thirdly, the NEC covers circuit protection, including overcurrent protection and ground fault protection, which are essential for preventing electrical fires and other hazards. Fourthly, it addresses overcurrent protection, including fuses and circuit breakers, which are used to protect electrical circuits from excessive current. Fifthly, the NEC covers grounding and bonding, which are critical for ensuring electrical safety and preventing electrical shock hazards. When deciding whether to use NFPA 79 or the NEC for control panels and PLC programming for machinery and conveyor systems, NFPA 79 is generally the preferred standard. The reason is that it provides more specific guidelines and requirements tailored to the unique safety concerns associated with industrial machinery. While the NEC does cover some general requirements for electrical wiring, it does not address the specialized considerations for industrial machinery, such as the use of safety devices, control devices, and motor protection. NFPA 79 provides clear guidelines for the design and installation of control panels. This includes enclosure requirements, equipment mounting, and wiring layout. NFPA 79 provides detailed specifications for PLC programming. This includes safety programming practices, hardware selection, and system testing. NFPA 79 also has requirements for specific safety devices, such as emergency stop buttons, interlocks, and safety mats. To elaborate on specific aspects of NFPA 79, consider the requirements for control panel enclosures. NFPA 79 specifies the types of enclosures that are suitable for different environments, taking into account factors such as dust, moisture, and corrosive substances. The standard also provides guidance on the size and construction of enclosures, ensuring that they are adequate to house the electrical components and protect them from damage. Regarding equipment mounting, NFPA 79 provides guidelines for how electrical components should be mounted within the control panel. This includes requirements for spacing, ventilation, and accessibility. The standard also specifies the types of mounting hardware that should be used to ensure that components are securely fastened and will not come loose during operation. When it comes to wiring layout, NFPA 79 provides detailed specifications for how electrical conductors should be routed within the control panel. This includes requirements for wire bundling, labeling, and separation of different types of circuits. The standard also specifies the types of wiring methods that are permitted, such as conduit, cable tray, and direct burial. Turning to PLC programming, NFPA 79 addresses safety programming practices. This includes requirements for the design of safety functions, such as emergency stop circuits and safety interlocks. The standard also specifies the types of programming languages that are permitted and provides guidance on how to validate and verify safety software. In terms of hardware selection, NFPA 79 provides guidance on choosing the appropriate PLC hardware for the application. This includes requirements for the processor, input/output modules, and communication interfaces. The standard also specifies the environmental requirements for PLC hardware, such as temperature, humidity, and vibration. Concerning system testing, NFPA 79 requires that all PLC systems be thoroughly tested before being put into operation. This includes functional testing, safety testing, and environmental testing. The standard also specifies the documentation that must be maintained for PLC systems, such as schematics, wiring diagrams, and test reports. Regarding specific safety devices, NFPA 79 provides detailed requirements for emergency stop buttons. This includes requirements for the color, size, and location of emergency stop buttons. The standard also specifies the types of circuits that must be interrupted by emergency stop buttons, such as motor control circuits and power supply circuits. NFPA 79 has requirements for interlocks. This includes requirements for the design and construction of interlocks. The standard also specifies the types of houses that must be protected by interlocks, such as moving parts and high-voltage circuits. Furthermore, NFPA 79 provides requirements for safety mats. This includes requirements for the size, shape, and location of safety mats. The standard also specifies the types of circuits that must be activated by safety mats, such as emergency stop circuits and alarm circuits. Although the NEC may be applicable to certain aspects of electrical systems and machinery, NFPA 79 is the more comprehensive and appropriate standard for control panels and PLC programming in industrial machinery and conveyor systems. By adhering to NFPA 79, the safety and reliability of electrical systems can be better assured. Let's delve into some practical examples of how NFPA 79 applies to specific scenarios within industrial machinery. Imagine a robotic welding cell. This complex piece of equipment involves multiple motors, sophisticated control systems, and potentially hazardous processes. NFPA 79 dictates how the control panel for this welding cell should be designed, wired, and protected. Firstly, the enclosure of the control panel must meet specific standards for environmental protection, guarding against dust, fumes, and weld spatter. Secondly, the wiring within the panel must be meticulously organized and labeled, adhering to NFPA 79's guidelines for conductor sizing, routing, and termination. Thirdly, safety circuits, including emergency stop buttons and light curtains, must be integrated into the control system in accordance with NFPA 79's requirements. Another example is a large conveyor system used in a packaging plant. This system might involve hundreds of feet of conveyors, numerous motors, and a complex network of sensors and control devices. NFPA 79 guides the selection and installation of these components, ensuring that they meet the necessary safety standards. Firstly, motor overload protection must be implemented in accordance with NFPA 79's guidelines, preventing motors from overheating and potentially causing fires. Secondly, safety interlocks must be installed at various points along the conveyor system, preventing access to hazardous areas while the system is in operation. Thirdly, the control system must be designed to safely stop the conveyor system in the event of an emergency. To further illustrate the differences between NFPA 79 and the NEC, consider the grounding requirements for electrical equipment. The NEC provides general guidelines for grounding electrical systems in buildings, but NFPA 79 provides more specific requirements for grounding electrical equipment in industrial machinery. Firstly, NFPA 79 requires that all exposed metal parts of electrical equipment be bonded together to form a low-impedance ground path. Secondly, the ground path must be sized to safely carry fault current back to the source. Thirdly, the ground path must be regularly inspected and tested to ensure its integrity. Regarding overcurrent protection, The NEC provides general requirements for protecting electrical circuits from overcurrents, but NFPA 79 provides more specific requirements for protecting electrical circuits in industrial machinery. Firstly, NFPA 79 requires that all electrical circuits be protected by overcurrent devices, such as fuses or circuit breakers. Secondly, the overcurrent devices must be sized to protect the conductors and equipment they supply. Thirdly, the overcurrent devices must be located in readily accessible locations. To delve deeper into the technical aspects of NFPA 79, consider the requirements for conductor ampacity. Conductor ampacity refers to the maximum amount of current that a conductor can safely carry without overheating. The NEC provides tables that list the ampacity of various types of conductors, but NFPA 79 provides additional guidance on how to direct conductor ampacity in specific applications. Firstly, NFPA 79 requires that conductor ampacity be directed when conductors are installed in raceways or cable trays. Secondly, conductor ampacity must be directed when conductors are exposed to high ambient temperatures. Thirdly, conductor ampacity must be directed when conductors are bundled together. Another important aspect of NFPA 79 is the requirements for control circuit wiring. Control circuits are used to control the operation of electrical equipment such as motors, solenoids, and relays. NFPA 79 provides detailed guidance on how to wire control circuits, including requirements for conductor sizing, insulation, and protection. Firstly, NFPA 79 requires that control circuit conductors be sized to carry the maximum current that they will be subjected to. Secondly, control circuit conductors must be insulated to prevent short circuits and ground faults. Thirdly, control circuit conductors must be protected from mechanical damage and environmental factors. Furthermore, NFPA 79 addresses the use of programmable logic controllers, which are commonly used to control industrial machinery. PLC are essentially specialized computers that can be programmed to perform a wide variety of control functions. NFPA 79 provides guidance on how to safely integrate PLC into industrial machinery, including requirements for safety programming, hardware selection, and system testing. Firstly, NFPA 79 requires that PLC programs be designed to prevent hazards, such as unexpected machine movements or equipment malfunctions. Secondly, PLC hardware must be selected to meet the environmental and performance requirements of the application. Thirdly, PLC systems must be thoroughly tested to ensure that they function correctly and safely. The application of NFPA 79 also extends to human-machine interfaces or HMI, which are used to provide operators with information about the status of the machinery and to allow them to control its operation. NFPA 79 provides guidance on how to design and install HMI in industrial machinery, including requirements for screen layout, operator controls, and safety features. Firstly, NFPA 79 requires that HMI screens be designed to be clear, concise, and easy to understand. Secondly, operator controls must be located in readily accessible locations and must be clearly labeled. Thirdly, HMI must include safety features, such as emergency stop buttons and alarm indicators. In summary, while the NEC provides a broad framework for electrical safety in buildings, NFPA 79 provides specific and detailed requirements for electrical safety in industrial machinery. By adhering to NFPA 79, engineers and technicians can ensure that industrial machinery is designed, installed, and operated safely. This not only protects workers from electrical hazards, but also helps to prevent equipment damage and downtime. For example, NFPA 79 Section 13.2.4.1 states that control circuit conductors shall be sized not smaller than 1.0 square millimeter or 18 American wire gauge copper. NFPA 79 Section 5.2.3 states that equipment shall be suitable for the environment. For example, electrical equipment in a wet environment shall be rated for wet locations. NFPA 79 Section 12.26 states that overcurrent protection shall be provided for all ungrounded conductors. This protection is important for preventing damage from short circuits and overloads. Another critical area covered by NFPA 79 is the selection and use of disconnect switches. Disconnect switches are used to isolate electrical equipment from the power supply, allowing for safe maintenance and repair. NFPA 79 specifies the types of disconnect switches that are suitable for different applications, as well as the requirements for their installation and operation. For example, NFPA 79 requires that disconnect switches be readily accessible and clearly labeled. The standard also requires that disconnect switches be capable of interrupting the maximum fault current that they may be subjected to. To further illustrate the importance of NFPA 79, consider the potential consequences of failing to comply with its requirements. Firstly, non-compliance can lead to increased risk of electrical shock and electrocution. Secondly, non-compliance can result in equipment damage and downtime. Thirdly, non-compliance can lead to fines and other penalties from regulatory agencies. Fourthly, non-compliance can damage a company's reputation and credibility. Therefore, it is essential for all engineers and technicians who work with industrial machinery to be familiar with NFPA 79 and to adhere to its requirements. This will help to ensure the safety of workers, protect equipment from damage, and maintain compliance with applicable regulations. To provide additional context, it's helpful to understand the historical development of NFPA 79. The standard was first published in 1962 and has been revised and updated numerous times since then. The current edition of NFPA 79 is the 2021 edition. The standard is developed by a committee of experts from various industries, including manufacturers, engineers, and safety professionals. The committee meets regularly to review and update the standard based on new technologies, industry best practices, and feedback from users. The ongoing development of NFPA 79 reflects the evolving nature of industrial machinery and the need to continually improve electrical safety. For example, recent editions of NFPA 79 have included new requirements for safety-related control systems, which are used to protect workers from hazards such as moving machine parts and high-voltage electricity. These systems typically involve a combination of sensors, control devices, and safety interlocks that are designed to prevent accidents and injuries. Another important trend in industrial machinery is the increasing use of automation and robotics. NFPA 79 has been updated to address the specific electrical safety requirements for automated systems and robots, including requirements for safeguarding control circuits and emergency stop systems. These requirements are designed to protect workers from the hazards associated with automated equipment, such as unexpected movements and collision. It's also important to note that NFPA 79 is often referenced in other standards and regulations. For example, the Occupational Safety and Health Administration, or OSHA, often refers to NFPA 79 in its regulations for industrial machinery. This means that compliance with NFPA 79 can help companies to meet their obligations under OSHA regulations. In addition to OSHA, many other regulatory agencies and organizations recognize and reference NFPA 79. This underscores the importance of NFPA 79 as a widely accepted and respected standard for electrical safety in industrial machinery. Moreover, NFPA 79 is not only applicable in the United States but is also recognized and used in many other countries around the world. While some countries may have their own national standards for electrical safety, NFPA 79 is often used as a benchmark or reference document. This international recognition of NFPA 79 reflects its comprehensive and well-established approach to electrical safety in industrial machinery. To summarize, NFPA 79 is the preferred standard for electrical safety in industrial machinery due to its specific and detailed requirements tailored to the unique hazards associated with this type of equipment. While the NEC provides a general framework for electrical safety in buildings, it does not address the specialized considerations for industrial machinery. By adhering to NFPA 79, engineers and technicians can ensure that industrial machinery is designed, installed, and operated safely, protecting workers from electrical hazards, preventing equipment damage, and maintaining compliance with applicable regulations. Remember that proper application of NFPA 79 requires a thorough understanding of the standard and its requirements. It's essential to consult the latest edition of NFPA 79 and to seek guidance from qualified electrical engineers and safety professionals when designing and installing electrical systems and industrial machinery. In conclusion, NFPA 79 is a critical standard for ensuring electrical safety in industrial machinery. By understanding and applying its requirements, it's possible to create safer and more reliable industrial environments.